One of the most common properties that we refer to in science and engineering of fluids is density. Density, usually symbolized by the Greek letter rho, is a measure of the mass of a fluid per unit volume. The units then would be in kilograms per meter cubed. Sometimes it's written as dmdV using the calculus version. dmdV is also acceptable for density. The next quantity would be specific volume. And specific volume, in simplest terms, is merely 1 over rho, 1 over the density. We sometimes use the symbol V to indicate specific volume, and so the units in this would be volume per unit mass. And this, of course, would be meters cubed per kilogram. So specific volume is the volume that's occupied by a unit mass of a fluid. Another property is the specific weight. And the specific weight is symbolized by the symbol gamma, and this is the weight per unit volume. So this would be, notice not mass, but it's weight per unit volume. It is not as common as density is used, but nevertheless it does appear occasionally in various aspects of physics. So just be aware of this particular property called the specific weight. Another significant property is that of specific gravity. And specific gravity of a fluid is measured this way. We take the ratio of the density of the fluid and divide it by the density of water. So it becomes a dimensionless quantity. It just shows how dense that fluid is compared to the density of water. Something that's more dense than water would have an SG greater than 1. And something that's less dense than water would have a specific gravity that is less than 1. Now, since this is really mass per unit volume, this is also mass per unit volume, if we take care of the gravitational constant, we can tie this back into specific weight by taking gamma over the gamma of water. So it could easily be considered as weight per unit volume divided by weight per unit volume of water. When we speak of the pressure of a fluid, it's usually measured with respect to one of two possible references. So the pressure could be measured either with respect to 0, or it could be measured with respect to the atmosphere. When we measure it with respect to 0, the result we come up with is called absolute pressure. When we measure it with respect to atmospheric pressure, it is known as gauge pressure. And these two are slightly different. Most pressure gauges read the excess of pressure over atmospheric pressure. So to distinguish between them, the letters A and G are usually added to the unit symbols in the unit system. However, since we're using mostly the SI system, the words gauge and absolute can be added to the measurement. So we can say things like so many kPa absolute or so many kPa gauge. Now, there's a connection between them. If we know the pressure with respect to absolute, we can relate it to the pressure measured by a gauge by this relationship. P absolute is equal to P gauge plus the pressure of the atmosphere. Typically, the standard atmospheric pressure is about 29.921 inches of mercury. That's one way of measuring it. Or it could be measured as 101.3 kPa. Or it could be measured as 14.696. This would be in terms of pounds per square inch absolute. So these are three different numerical ways with the proper units: inches of mercury, kPa, and pounds per square inch absolute. Now, there are times when the gauge pressure could be negative. And when it's negative, that means we're dealing with a vacuum. Then the absolute pressure will be obtained by subtracting the gauge pressure from the atmospheric pressure. So we end up with a much smaller number for P absolute compared to P atmosphere.